Hello, today we are going to introduce the OneAIOps. OneAIOps is the AI-based platform for intelligent management of cloud edge environments. First of all, we will introduce the architecture and different components of OneAIOps. Then, we will proceed with a few demos. Installation of OneAIOps package and configuration of the AI-driven service for resource usage prediction. We will show how the Insight server can be integrated with the monitoring and alerting system to generate alerts for the resource usage predictions. We will show how to use the OneAIOps command line for training and evaluating the AI machine learning models to be integrated in OneAIOps. Then you will see how to access the AI-driven predictions using the OneAIOps Python software development kit. OneAIOps architecture consists of multiple components. Monitoring system provides an access to the real-time metrics and historical observations that are related to the components and entities of an OpenNebula cloud deployment. It uses Prometheus for metrics gathering that are related to the infrastructure and virtual resources. Alerting system triggers events and notifications and then routes them appropriately to the right components based on the alerting rules. It is based on the Prometheus Alert Management Server. One AI Ops software development kit is the Python-based API designed to interact with OpenNebula cloud deployments. It allows the retrieval of information about OpenNebula entities such as virtual machines and hosts, access the historical data related to the entity metrics, and generation of metric predictions. Machine learning artifact is defined as a collection of files required to integrate the AI/ML method within the one AI ops. It consists of the manifest file, the checkpoint file storing trained parameters, and the machine learning model configuration file. Within one AI ops, different machine learning artifacts for time series predictions have been integrated, such as ARIMA and Moira AI. Registry is responsible for dynamic definition of metrics related to the OpenNebula entities, such as hosts, virtual machines, and data stores. In particular, for each metric, the registry specifies how to retrieve historical data stored in the monitoring system and which machine learning artifact to use for metric predictions. Insight Server provides predictions related to metrics, such as CPU usage, that are defined in the registry. The predictions can be accessed through the REST API and are exposed in the Prometheus format, thus it can be integrated with the monitoring and alerting system. Orchestration Server produces plans about optimal placement of virtual machines according to the set of policies and changing conditions in the state of the cloud resources. Plan Executor is responsible for interacting with the OpenNebula cloud environment to execute plans generated by the orchestrator. Each plan outlines the desired future state of the OpenNebula system as determined by the orchestrator in the response to scheduling request or workload optimization. One AI Ops command line provides a declarative tool to manage and automate the training and evaluation of machine learning models. The command line adopts a configuration driven approach, specifying training and evaluation settings via the configuration files. This configuration driven setup allows to manage model training and evaluation with minimal coding. The command line allows training and testing the machine learning models using metrics from the monitoring system or synthetic data tailored for the specific test scenarios. Let's start with the installation of one AI Ops. Here we show how to install the OpenNebula AIOps package using the OpenNebula repository. The used command is the following: sudo apt install OpenNebula-AIOps. In order to export the AI-driven predictions provided by the Insight server to the Prometheus server, you need to patch the Prometheus configuration file by running a specific command. This command can be found under the user share 1 Prometheus directory and has a name patch underscore datasources.rb. After the command is executed, we can find two extra sections that were added by the script to the Prometheus configuration file that's located inside the etc1 Prometheus. This refers to two API endpoints of the Insight server that allows exporting the predictions of virtual machines and hosts to the Prometheus. After the file was patched, restart the Prometheus server by executing systemctl restart OpenNebula-Prometheus. You also need to start the OpenNebula Insight server. You can do it by simply running systemctl start OpenNebula-Insight. This is the server that runs two API endpoints in order to export predictions to Prometheus. Prometheus will call these endpoints on each scrape interval, and the Insight server will export the predictions to Prometheus. Once the AI Ops is installed and Insight server configured, we can proceed to see how the monitoring and alerting system can be used to trigger alerts based on the predictions of the infrastructure and the virtual resource usage. Let's look at the current state of our OpenNebula instances. Run one host list to list all the available hosts, and run one VM list to list all the currently running virtual machines. This is the Prometheus query browser. We can find the CPU seconds total metric that represents the total CPU time in seconds of a virtual machine. The Insight server uses the observations related to the CPU seconds total in order to build the prediction for the CPU usage of a virtual machine. The Insight server provides the predictions through the REST API and represents them in the Prometheus format. Firstly, let's verify that the server is up and running. The Insight server provides two endpoints, one for hosts and another one for virtual machines. We can see from the log that Prometheus is scraping every 5 seconds. From the Prometheus query browser, we can see that the predictions are pulled. For example, we can search for predictions related to the CPU usage that is exported by the Insight server for two virtual machines that are running. As you can see, the label with forecasting horizon is present. By default, the Insight server does predictions for the next minute. For each of the metric predictions exported by the Insight server, we have defined some rules for the alert manager that will raise an alert when the prediction exceeds a certain threshold. In particular, we have defined a rule that will create an alert when forecast predicts that a specific virtual machine exceeds the 85% of the CPU usage for the next minute. In order to trigger an alert related to the forecast of the CPU usage, we are going to increase the usage of the CPU for one of the VMs using a specific script. Once the forecast model predicts a value that is above the threshold, the alert is going to take off. From the Alert Manager web UI, we can see that an alert has been triggered for the prediction with a high CPU usage. And we also can find out which virtual machine has triggered the alert, the severity associated with the alert, and the actual value of the metric. By default, the Insight server uses a REMA model for the forecasts of the metrics that are in the registry. In the following demo, we are going to show how the registry is defined and how to use the OneAIOps command line to train, validate, and integrate an AI model with OneAIOps. The main purpose of the machine learning registry is to dynamically define the metrics related to the OpenNebula entities, such as virtual machines, hosts, data stores, and etc. In particular, for each metric, the registry should specify how to retrieve historical data stored in the monitoring system, accessor selection, and which machine learning model to use for metric prediction selector. There is a default section that defines the default accessor and forecast model. If not configured, the default settings are going to be applied. If we want to use a different machine learning model for forecasting the specific metric, we have to change the registry configuration file. In this case, we're going to show how to change the default forecast model for predicting CPU usage of a virtual machine. The OneAIOps CLI can be used for different operations. In order to use the OneAIOps command line, we need first to define a manifest file related to the machine learning model. This manifest file specifies the type of prediction model that you want to use and the path to the configuration file related to the model that you would like to train. This is the configuration file of the transformer model. Here are some of the parameters you can define. Model class, the class of the model that we would like to train. In our case, the transformer model. Hyperparams, parameters of the transformer model. Training params, parameters related to the training configuration. Sequence length, number of historical observations needed to generate the forecast. Now, we're going to train the transformer model using the train command of the OneAI command line. The command uses the following parameters: virtual machine, OpenNebula entity for which we would like to obtain the data used for training, CPU usage, metric name for which we want to obtain the data used for training, -40M, -15M, 10S. Time range for which data will be collected to train the model. In this case, we get the historical data that goes from the past 40 minutes until 15 minutes ago with the resolution of 10 seconds. Manifest path, path to the manifest file of the related model that we would like to train. Manifest save path, path to save the updated manifest file. Checkpoint save path, path to save the trained machine learning model weights. Model config save path, path to save the trained machine learning model configuration. Now we're going to evaluate the performance of the training model on predicting CPU usage of the virtual machines. This reports the different quality metrics related to the performance of the model predicting this metric with this period of time. Once model is trained and has been evaluated, we can integrate the model in the OneAIOps framework by changing the registry. In particular, this is done by modifying the etc. OneAIOps registry.yaml file and adding a prediction section inside the virtual machine and CPU usage sections. This prediction section includes the path to the manifest file of the trained model. Finally, we also show how to use OneAIOps software development kit to access the AI-driven predictions. First of all, we launch a Python 3 interactive shell. The Python path should be set to the folder where the Python packages that are related to OneAIOps are installed. In order to access any information related to OpenNebula deployment, we need to import by OneAI package and instantiate the One class. Then you can get the collections of hosts and collection of virtual machines and their IDs that correspond to a specific OpenNebula deployment. Then we access the specific virtual machine with the ID 5. Using the following command, we can access the historical data of the CPU usage of the virtual machine with the ID 5. By running this command, we can access the historical and predicted future data of the CPU usage of the virtual machine with the ID 5. Predictions now are done with the transformer model that we have trained with OneAI command line and integrated into the registry. Lastly, we can access the historical and predicted future data of another metric like the normalized CPU usage. In this case, the prediction was performed by the default module of the registry, statistical ARIMA model. The OneAIOps was developed in the context of ONEnextgen project under the IPCEI cloud. Thank you for watching and see you in the next video.